not smart. Computers are designed to be very, very quick, but they also obey a law called garbage in, garbage out, which means if you put a bunch of crap into them, they're going to do a bunch of wonderful math on crap entry. So you got to make sure that you take out what you don't want it to be looking at. So, that's okay. Bueno. That's not French. How do you say? Très bien? Yeah. Très bien. Oh. It has to follow with the all, right? Maybe.
Stern French is turning in there.
These are jokes, kids. These are jokes. I'm going to do a Zoom 9. Friends. You know, it's funny. When I hear people complain about Bachelor, and I see that, I'm gonna make it bigger. Let me turn off the graphic for a second. Oops, and turn off the graphic. That's the scatter plot from 1978, I believe was the, no, 1983 to 2007. When I hear people complain about Bachelor, there's all kinds of legitimate reasons to complain about businesses. I mean, I'm not saying any business is immune from criticism, but this, there's nothing to complain about. They have raised their prices linearly for 2.5 decades, from 83 to 2007. They're actually giving you a gift with that data. Do you know why? Why do they have to raise their prices?
Stay in business.
To stay in business, why?
Inflation.
Because of inflation. Because $1 in 1983, I know this for a fact from yesterday, $1 in 1992 is worth $1.55 in 2010. 55% inflation from 92 to 2010, only because I cranked it yesterday using some governmental data. $1 in 1992 is $1.68 in 2014, current years. 68% inflation. Now the reason why I get so excited seeing what looks to be a perfectly straight line, that's not exponential. That's slower than exponential. Exponential grows as a curve because a percentage is applied to a base, which means it's multiplicative, not additive. Remember what linear means. Remember what a slope means. It's a certain unit per unit time added on. 1.05 plus 1.05 plus 1.05 plus 1.05. That's plus. Inflation is multiplicative. You take a certain percent of a base, add that in, then multiply by that percent again, add that in, then that percent again, add that in. It's multiplicative, which is going to grow faster than linear. Which means they were actually undercharging you at some point in here. They were undercharging you for inflation. Isn't that? You're not as impressed as I am. I'm wickedly blown away by this. We'll come back to exponential growth soon, Ryan.
But a majority of the time they're overcharged.
Well, hang on now. We're going to get back into that. We're going to get back into that. I want to know right now, assuming this exists, what should a single, this is a single day pass cost at Bachelor? Use your model. Hey, we don't have a model yet, do we? We haven't come up with the model. Here we go. Let's make the model stat calc, lin reg. This is the same thing we did for uninsured, yes? Same thing we did. I'm going to stick it in Y1 while we're at it. All I'm doing very quickly is going through the booklet, yes? With new data. Here's the model. Boom! Say that again, Whitney.
Mine isn't doing it.
It's not doing what? Scatter plot?
Yeah.
Make sure the plot's turned on.
It is.
You sure?
I went and did the
Zoom 9?
Yeah, mine looks funny.
It looks funny. Check your data. Oh, Zoom 9. Zoom 9. That means you got a data point that's off. I can see them.
Zoom 9.
Right there. Well, get rid of them. Fix them. Don't. Wait, let me see yours.
I did it. I got it. I didn't do Zoom 9.
Damn me and my booklet. The booklet is a gift, friends. The booklet. You hate reading? I'm sorry. You hate. I heard I hate reading. I'm sorry. I hear things and I see things. I got issues. The booklet is a gift because if you follow the booklet for every data set, you will bomb-proofly get through. Bomb-proofly, it's a new adjective. Bomb-proofly get through anything I ask you to do with regressions. So just take your time. Take your time. It sounds like Tammy, your data's off a little bit. Just go back in and look at it again. Maybe you've got the original data on top of the new data. Pull the original data out, the uninsured data. You may have to get rid of that first. We'll take a look in a minute. Get your model. What does this mean? What does this mean? On average.
$1.55 per year.
God, I love the word more too, because you have to. Because it's positive. I'm going to assume you mean more, because it's positive. Yes, it's positive, which means on average, Bachelor ups their ticket price by $1.55 each year. Now, if you look at the data, you can kind of see that. I mean, there's $1, there's 2, there's 1, there's 2, there's 1, there's 2, there's 3, there's 2, there's 0. This is why you don't put those zeros in, yes? You put the zeros in, it's going to drive that average down artificially because it's going to make it seem like there were a couple years it dropped like 35 bucks.
Then it actually puts down a placeholder.
Exactly, that placeholder isn't there necessarily. So when you have missing data like this, just leave it out. Did you see in your graph where those missing data points are? Right there. That's the 21 and the 23 you left out. The TI will hold the place for you. No, not a problem at all. Fair enough? Good. Okay, let's turn. Actually, we can use him. What would this mean if it had a meaning that was important? In 1980, right? Right. In 1980, since we used that as our base year, remember how we called 83.3? That means 3 years from 1980. In 1980, the model predicts the ticket would have been 12 bucks a day. That's what the prediction is. Now, I told you guys yesterday, I'm way more of a fan of the slope than the y-intercept. Because the slope is really, the y-intercept is a function of what you decide to call year zero. We could have called 1983 year zero, yes? But I mean, I don't think there's any point to that because then it just becomes hard to like label them correctly. It's easier to do it this way. Cool? All right. No, not cool.
Why did I get it? I don't understand why I got 1.68.
It's a data entry issue. Guaranteed. Guaranteed. If you're getting different numbers than we are, it's just something got entered wrong. Guaranteed. I'm not criticizing. I'm not criticizing. Same thing with Whitney. Same thing with Tim. I'm not criticizing. I'm just, when I say data error, we're humans. We make those kinds of errors. That's why I like doing it all together. So that way, when you guys see the results I got, and we've got them all, one person or two people get off, they go back and look at their data, and they fix them. Fair? So how much should a ticket have cost in 2014?
Should be like
$79.
So, how'd you do it, Ian?
I just looked at their website.
Oh, hang on! Wait, keep that out! Please, don't put that away! I was going to do that next. You saved me the time. How do we find it very quickly using our TIs?
31.
How do we do it very quickly using our TIs? Is that the easiest way? I don't think so.
For me.
No! Oh God, no! What's the easiest way? Question, what variable do you have? X. So which tool should you use?
Table.
The table! The table allows you to put the X directly in and it pops out the Y. You know that Y equals 1.55X plus 12. What is X in this case? 34, I believe? 2014 is 34 years past 1980. So you would go straight to your table and just run 34 years in there. It should cost about 65 bucks this year. Ian, how much is it actually?
79.
79, which means somewhere between 2007 and now, what happened?
Power core bottom nose.
Well, I didn't want to say that, but somewhere between, I want to say a little more diplomatically if it's okay, Ian. Somewhere between 2007 and 2014, the pattern in the growth of ticket prices changed. It's no longer the same slope. The slope obviously increased somewhere. Because if you look at that, see, check it out. That's what our data looks like, yes? Now, I'm going to put 2 more data points onto this, but leave that line on. I'm going to go back into my stat editor, and I'm going to go down here past my last data point, which was, I'm going to put, we're at 30, you're 34, yes? I'm going to put our predicted value, which was $65, and the actual data point, Ian, which was 79 bucks. I'm going to do a zoom 9, okay? There they are. Here comes that's our predicted value. That's what it actually is. This is the, I didn't say it. But so at some point between 2007 and 2014, something changed. And I don't have the data between 2007 and Ian's current data of $79. So at some point, maybe it was as simple as this. Maybe all of a sudden Bachelor was like, holy crap, inflation does exist. We need to actually like start charging for inflation. Or maybe it's something else. I don't know. But that's the danger of extrapolation. Because if you took too far outside of your data set, then you can be off by, say, $10, $15. Ryan, go ahead.
Wasn't around 2007 they were bought out by that Switzerland company?
By who?
There was some sort of Switzerland company. That
Sure. Sounds good.
corporate thing.
And that could be the explanation. That's what statistics is wonderful for. It raises more questions sometimes than it answers. It says, wait a minute, why is this so different? Then you go back and look at it again. Oh crap, that's why. Like yesterday in that negotiations meeting, people's jaws hit the table. Well, not literally, they would become off their face, but they were like, that can't be right. Like, no, that is right. That's called arithmetic. But if people don't think to look at until they see a brief synopsis of it like this. Holy crap, this is actually telling at that point, yes? Make sense? Hopefully fair. Hopefully fair. Good. Any questions so far? We getting there? We're getting there, maybe. I want to re-answer Alicia's question better, I think. Is everybody okay with the technical of getting the data in, getting the best fit line, using a table, using the intersect, solving the equation? We're getting there. Good, good. We're going to build on that on Tuesday.